Witnesses to a crime will often be asked to identify the perpetrator of the crime. So this means that witnesses need to remember the face of the suspect. So it's worth us spending some time understanding how people recognise faces, as this has implications for how we deal with this issue during an investigation. One technique for getting eyewitnesses to recreate an image of the face of the criminal is known as PhotoFit, originally known as Identikit. This involves eyewitnesses reconstructing a suspect's face feature by feature using a library of different features. However, there is a problem with this. The problem is that the technique has been found in multiple psychological studies to be very poor. Can psychology tell us why PhotoFits are so poor at producing recognisable likenesses? Psychologists have been researching face recognition for a long time. One of the key early findings was a phenomenon known as the inverted face effect. This was investigated in an experiment by Robert Yin of the Massachusetts Institute of Technology. He showed participants a series of pictures of faces, as well as other types of objects, such as houses and aeroplanes. Then he gave everyone a recognition memory test on the items, where he showed them pairs of pictures in which one had been previously shown and the other was new. Participants had to choose which of the pictures they'd seen previously. Crucially, some of these picture pairs were presented upside down. And here's the results. On the vertical axis, we have the number of identification errors they made. What Robert Yin found was that people had proportionally greater difficulty recognizing upside down faces as compared with other types of object. So, most people should find these faces proportionally harder to recognize upside down, but easy to recognize the right way up. Yin interpreted this as indicating that the mechanisms we use for face recognition are inherently different from those we use for processing other classes of objects. He suggested that in our brains there is a processor that specializes in dealing with human faces. This idea has since been supported by lots of different strands of evidence, such as patterns of brain damage, neuroimaging studies, and behavioural experiments. It's been argued that the reason that faces have their own special recognition mechanism is because they're a class of stimuli that we've been exposed to every day of our lives, and we have become super expert in telling apart faces. That is, our brains have developed a specialist recognition system for faces because, as social animals, we have to be able to recognise faces. We have to be able to tell people apart. So why does being super experts in recognising faces mean that they're proportionally harder to detect upside down relative to other objects? Martha Farah of the University of Pennsylvania proposed that we recognise objects via two mechanisms that are housed in anatomically different areas of the brain. The first mechanism for recognising objects is via the strategy of decomposing the object into its component parts or features. So if we were looking at something like a building, our brain dissects it into features such as its doors, windows, and so on, and analyses whether it is a familiar building or not based on those features. The second object recognition mechanism involves a more holistic approach where we recognise objects as an undissected whole, where our brains are explicitly not breaking the object down into its component features. Martha Farah argues on the back of a considerable amount of research that faces are an extreme example of a class of object that is recognised almost entirely holistically and only a tiny part by dissection. So when we look at objects, we can use both these strategies, but the proportion of each that we use depends on the type of object. For most everyday objects such as houses, aeroplanes, printed words and so on, we rely much more on our feature-based recognition system. However, for certain overlearned objects like faces, we rely much more on the holistic strategy. This means that when we look at a face, our brains are not attempting to dissect it into its component features. And what she argues is that this is the key difference that means that we find faces harder to differentiate when they're inverted. When you turn something, usually something that's only seen upright, upside down, the idea is that if it's something that we recognize mainly on the basis of features, through the analysis of its parts, like buildings or aeroplanes, then it won't matter so much. However, if it's something that we recognize more on the basis of holistic information, then it will matter more. This holistic information is proportionally much more likely to be impaired by inversion, which is exactly what Martha Farrad's experiments appear to demonstrate. In the next presentation, I'll explain what all of this work on face recognition tells us about photo fits and whether it could lead to a better way of helping eyewitnesses generate the likeness of a suspect.